to move on to our final speaker of the session today. It's Jacob Podgorny. I apologize if I got that name wrong, pronunciation. And he'll be talking on modeling reflected X-ray polarization from black hole accretion disks. So please start, and I'll give you a 3-minute warning.
Hello. I hope you can hear me well as well online.
We hear you.
Okay, cool. My name is Jakub Podgorny, and I would like to present to you an ongoing project that we are doing with my PhD supervisors, Michal Dovčák and Frederic Maran, and other collaborators, namely Giorgio Mat, René Guzman, Agata Rožanská, and Dominik Gronkiewicz. And I would like you to present a new class of models that we are preparing for the black hole accretion disk community, and that includes that is about X-ray polarization reflection studies, and includes Monte Carlo methods. So this work is kind of complementary to the reflection studies done by the group of Henryk Krawczynski. And so far, we have achieved results for active galactic nuclei, and we are in the process of adapting these models to the X-ray binaries. And so far, we have departed from the Lampos model, which is for us the easiest, although it has acquired a lot of criticism also on this conference. But we are beginning with testing the extended sandwiching coronal scheme too. So let me first give you a few technical details on the way we are doing the local reflection computations, because first we begin with reflection in the local comoving frame, and then we use integration routines over the accretion disks using the general relativistic computations. And first we precompute the ionization structure of the disk using radiative transfer code Titan. And we also played with the radiative transfer code Cloudy, but so far we are more confident with the results with Titan, so I will present those. And we assume plane parallel geometry and very simply just constant density. And for the X-ray binaries, we are adding thermal blackbody radiation in the X-rays. And then once we have the ionization structure computed, we insert it as an input into Monte Carlo simulator Stokes that is being developed by Frederic Maran. And that allows us to study all of the Stokes parameter with respect to local model parameters, such as the ionization parameter, primary power law index, and the incident emission inclination angles, as well as the azimuthal emission angle and primary polarization, because also the primary radiation can be polarized due to comptonization. And we already achieved local reflection tables for AGNs for lower densities, which are ready to be published in the FITS OGIP standard. And at this point, we can try to compare the spectral part with the silver reflection tables that are being commonly used and that are obviously more sophisticated, and we can use that as a cross-check, and we can compare this numerical Monte Carlo computation with the Chandrasekhar's analytical approximation for the polarization part, and see how we depart. So I don't have much time to go into detail, but I will just give you brief results that we are getting for the AGN so far, where the thermal component, the blackbody, is not included in the X-rays. And at the top left, you can see the reflection spectra that we are getting evolving with the ionization parameter. On the top right, you can see the polarization degree with energy, again with the ionization parameter. At the bottom right, you can see how the spectra are compared for similar parameters with the silver reflection tables. So we are quite happy that at hard X-rays we are getting remarkably similar results despite the completely different numerical technique used. And at the bottom left and middle, you can see the polarization degree and angle respectively versus different geometrical parameters, the different incident and emission angles. And here I try to show you how it compares to the Chandrasekhar's analytical approximation, which is in dashed lines, and our numerical simulation is in the solid lines. So in general, we are quite happy with the same geometrical evolution, and you can already notice that we are predicting a lower polarization degree due to the multiple scattering that is being properly included in our Monte Carlo Compton scattering simulation. And in general, we have a lot of ideas how to improve it. We need to include Comptonization, and we can, of course, add more flexibility to all the parameters that we are holding fixed so far. And the goal is then to provide high-resolution spectropolarimetric tables in the future to the public with respect to the upcoming X-ray polarimeters in the next decade that have been discussed in the previous talk. And for the X-ray binaries, we would like to depart and adapt the Stokes code in the version that the group of Roberto Taverna is using. And please check their latest paper. It's great work on polarization of the thermal emission, including absorption effect using the Stokes code. And also the poster of Lorenzo Mara on this conference is summarizing their work. And once we have the local reflection tables, we can then, of course, integrate them over the accretion disks and use general relativistic ray tracing codes to give a result for a distant observer. And for that, we are upgrading the KY codes that are being developed by Michal Dovčák and collective. And recently, we achieved a new version, which we now call KY and Stokes, that includes, of course, the latest Stokes local computations. And there has been other few technical updates because the last publication on this was 10 years ago. So we are preparing a new one that will include all of this. And of course, again, the long-term goal is to provide fast XPEC compatible models for the upcoming polarimetric mission that would include, that would be dependent on the global parameters such as spin of the black hole or inclination, and to be flexible in the basic toy model coronal geometries such as the lamppost model or the extended coronal model. So I can again give you some very brief results that we can already display for the AGN lamppost model. And at the top, you can see the reflection spectra for distant observer, how they evolve for different spin of the black hole or inclination, and when you switch different local reflection tables. And at the bottom left and right, you can see the polarization degree and angle respectively versus energy, how it again evolves with different global parameters such as spin of the black hole or inclination. And here also different primary polarization, as there is expected non-zero primary polarization from the corona. And again, I put in dashed lines the Chandrasekhar's analytical approximation that has been mostly used before for these kind of reflection polarization models. And again, in the hard X-rays for a distant observer, this is a total emission, including some primary source as lamppost. We are predicting a lower polarization degree in the hard X-rays because of multiple scattering included. And in future, it will be. Thank you. I have two last slides. it will be great to achieve the models for the extended coronal scheme, to finish the work on local X-ray binary tables, and to provide observational prospects for the IXPE, EXTP, or the XL caliber missions that were mentioned in the previous talk, and to give at least the average polarization fraction for a distant observer in their energy range with respect to different global parameters such as height of the lamppost or spin of the black hole or inclination. So just to summarize, we are exploring various numerical codes and developing them with the aim to provide fast XPEC compatible X-ray polarimetric models. We have done already a lot of work on the AGN disks and the X-ray reflection there. We would like to adapt the models to the X-ray binary disks to raise density and add a thermal component. And we start with the local reflection in the local co-moving frame from the accretion disks, and then we use general relativistic integrators to see how the results evolve for a distant observer. And we hope that this work will be in the next decade useful as a new class of models for the upcoming X-ray polarimetric missions. So thank you for listening, and I guess it's time for discussion.
Okay, thanks for being on time there. Do we have questions from the floor? And I will look on the Slack channel.
No question, apparently.
Well, while I continue to look for questions, let me ask a quick question. So you have the polarization set up for adding a reflection component. Do you have a base level of polarization modeling for the disk itself, sort of like the Jeremy Schnittman models that you then modify with the addition of the corona? So say, for example, can I model a disk going from a pure Novikov-Thorne disk evolving into a Novikov-Thorne disk with an additional coronal component?
Yeah, regarding adding these two components, we are, as I said, we are trying to merge also the work that the group of Roberto Taverna was doing on from the thermal component polarization with the reflection studies. It's in a process, and it is important to add reflection to it because due to the Compton scattering of the primary power law, we are expecting a high polarized fraction from the reflected component. So I don't know if I answered correctly what you were asking, but we believe that for consistent modeling, it is important to merge it into consistent models. I don't know.
I'll follow up in Slack, but Javier Garcia has a question. So Javier, why don't you go ahead?
Hi, thank you. This is great stuff. I'm very much interested in following up what you guys are doing. I want to, and I'm a little bit confused on the setup. If you can please clarify, you're using Titan to produce the reflection. Is there polarization in that reflection calculation, or is the polarization coming after when you do the Monte Carlo with the Stokes?
Mm-hmm. No, we use Titan just for power law illumination of the disk and to compute the ionization structure. And we use just the vertical disk structure, the ionization fractions as an input to the Stokes, which then has all the polarization calculations in it. Most importantly, the Compton downscattering. But has also other physics included.
I see. So Stokes is also solving what happens in the disk. It's not solving what happens in a corona, for example.
Yes, exactly. We use it for a disk, and the advantage is that it immediately gives you all of the Stokes parameters, and also it is very useful in a sense that it can account for incident primary polarization of the radiation that you can assign dependent on the coronal model that you use, because this radiation is also expected to be mildly polarized due to comptonization there.
Okay, great. Thanks a lot. Thank you. Great.
And if there is time, there is a question from Jörn here.
Yeah, let's take it and let's end with that, and I'll have a brief announcement after he's.
Yeah, I guess I'm still confused about what Stokes does. So does Stokes also do line radiative transfer?
Yes,
Okay.
both line and continuum.
So you just use Titan for the ionization structure, the vertical ionization structure, and this assumes constant density or a density profile?
Yes, it assumes constant density so far.
Okay, and the Compton scattering is using Kleine-Shiner effects?
Yes.
Okay, thank you.
I would be happy to give more details on Slack if anyone is interested.
Yeah, the Slack discussion for this session's been pretty lively, so everybody please go there. Before we end, just like to point out that for tomorrow's discussion sessions, Sarah and Pashek have started a Slack channel for session 9, which contains a questionnaire on multi-wavelength observations from Pashek, and a Google questionnaire from Sarah and Jörn. So please go fill those out, Slack channel for the session 9, and that will help guide the discussions tomorrow. And with that, let's thank all the speakers again for today's session.